Hello everybody, this is Ice, and welcome back to another video in the Minecraft Redstone Calculator tutorial series. In this video, we're going to be finishing what we started last episode, in particular, the device that shifts our inputs into the calculator. At the end of this episode, we'll hopefully have working input shifters, which should look really cool. It will be the first actual functionality of our calculator, and if we have extra time, we'll even start busing these inputs that we made in episode 1 over to here. Alright, so that looks pretty cool, and let's get started. So last time we got sort of a skeleton set up for our input shifters, and the first thing we need to do this time is synchronize them and actually connect them to some sort of timing circuit. So that's our first goal for today. To do that, what we're going to take advantage of is Minecraft's repeater lock feature, and in particular, we're going to have all these repeaters locked. Now, you might not quite get how these things work at this point, but I hope that when we start building this, everything will become clear. So the first thing you want to do is, we'll just do this for one layer and we'll stack it down. We'll come out 4 blocks like this and bust this all the way over. Obviously, we're going to need repeaters, which is sort of unfortunate, especially in this case, but it's fine. You're going to come and connect all this stuff, and of course then you're going to need to come back here and connect these little things here, like that. Now, of course, since we need to lock the repeaters, we need the repeaters going into their sides. So for instance, do this, do this, do this, and do this, and hey, look, do this too. So now we can go ahead and connect all this up. Of course, these lines will be inverted eventually. And before we do anything else, we want to stick on repeaters. Now, I think I've figured out where the repeaters should go in advance, but I'll just make sure. And of course, all these have wire on them too. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. So we have one repeater here just before the third one, and another repeater here just below the last one. So now we've connected this all up, and it should look like this. Now, if we stick a lever on here and flood this, then we'll see that all these top repeaters lock. Now the idea is that when we have a signal coming on here, nothing will happen. But when we pulse this, we'll see that the signal gets shifted in. And the idea is that if we were to pulse it again, if this lever isn't on, then it will get shifted out of this repeater lock and into this one. The problem is that for that to happen, we need all of these to be, well, how do I explain this? We need all of these to be in perfect synchronization. So for instance, this line here needs to take exactly as many ticks as that line. To do that, we'll make them all take 3 ticks. So we'll stick repeaters like this, and repeaters like this. We'll also put a repeater here and here, and now we'll see that each one of these will take exactly 3 ticks. Given that, we can stack this over, or stack it down rather, like this. And now you have the control line for your input shifter. Pretty neat. The next thing we want to do is hook up the timing circuit, which is, again, pretty easy. Timing circuits are never typically hard. What you want to do is come in here with 4 repeaters and 2 blocks up like this. What we're going to do is we're going to connect all these 4 repeaters with a glowstone tower. So that's what we'll do. We'll come up here, grab a block of glowstone here, one here, and stick them up here. So now you should have a glowstone tower, and all of these should be connected. So, that's that, and as of now, you should have something that looks a little like this, sticking on the back of your input 7-segment display. The next step is to build a monostable circuit that will be inverted and flood signals to this entire bit of redstone here. So to do that, you want to come and block out on this guy, like this, and grab a block and a repeater. This repeater is going to have 1 tick on it, and you're going to come in here with the torch. This will be your inverting torch, one of the more important torches in the calculator. So, as you can see, this will all go in and look pretty. On the other hand, we'll also need a 4-tick repeater here to make this into a monostable circuit. So this is the entire timing circuit for your input shifter. So let's test it out. So when we press this button, what we'll see happen is that all these things will get pulsed, all these repeater locks will turn off for a moment at the exact same time, which is great. So let's suppose I wanted to push the number 852 into the top input shifter. To do that, I'd start off by putting in the first digit, 8. This would be the equivalent of pressing the 8 button down there. So once I have an 8 going into here, I can simply hit this button and watch as the 8 signal is saved in this repeater lock. As we can see, I could use one of those compasses. As we can see, this is an 8. Great. Next of all, we need our 5, because we're doing the number 852. So we'll do a 1 and a 4, because 1 plus 4 is 5. Now, what will happen is that this 8 will get shifted over to this next digit, the tens digit, and the 5 will get put into this first one. Let's see if that works. And there's our 85. Finally, our last step would be to put in a 2, which is just 1, 2. And when we hit our button, the 8 will get shifted over to the hundreds place, the 5 to the tens place, and this 2 will go into the ones place. And now, if we look, we'll have an 852, which is pretty cool. Another thing that we'll have to do, and make sure to do, is have a reset switch for this. Now that's easy enough to do. Just come up here, 4 blocks, stick a sticky piston, another block below this, like this. And later on we'll have an inverter going into here. So there's that. And just to show you how you would reset this, normally this would be inverted and we'd have this sticky piston grabbing this block. When we turn it off, all of these wires will turn off and all of our numbers will get shifted over and go out the other end. So that's that. When we turn this back on, this happens and all good. Alright, so now we want to stack this thing, which is pretty easy. Again, we're going to need to stack the entire device for our input shifter from this block to this block. So to do that, we'll come down here and grab this as our bottom corner with World Edit. We'll come up here and grab this block here as our top corner. We just want to go up a little bit. Like, oh, actually, we don't want too much. Like that. Pause 2. And now we're going to copy this and paste it. So, again, nothing too difficult. I'm going to copy it from this block here. So do / copy. Come down here and do / paste. And did this work? Probably didn't work, but it worked. So that's good. I'm actually surprised that that did work. So now you have your 2 input shifters set up. And now that we don't have to stack extended pistons anymore, which is a hard thing to do, you can go up here, put a torch here, like so, and a torch here, like this. And you've now finished the setup for your input shifter. Very nice. Alright, so we're under 10 minutes in this episode, which is surprising. But what that means is that we'll have plenty of time to start busing these signals from here into these input shifters. Now, the way to do busing in a big Redstone project is not to start at the beginning and go to the end. Instead, you want to backtrack, starting from the end and heading on back to the beginning. Now, this is going to be quite the long bus, but again, World Edit can help us always, and that's pretty good. So the first thing we want to do is... Oh, and another thing I should mention. One might ask, how are these monostables ever going to get activated? Because, of course, the input shifters are useless if you don't activate these buttons here. The answer is that I think when we started this in episode 1, I made this thing connected to the 0 button, which looks like this. Now this is a piece that will turn on regardless of what button you press, and in particular, when we bus this over, this will go into the monostable. So that's how that will get activated. And yeah, so the next step is, of course, busing, which is always the funnest part. Alright, so let's get started. The first thing you want to do is come out here 5 blocks. 1, 2, 3, 4, 5. And come down. Now our goal here is to get all these things on a horizontal level. So, for instance, in this second one, we'd come out some more blocks like this, and come down here. This just so happens to work out very, very nicely, like that. Next is, of course, this block. Pretty simple, and this one is at the bottom. So this one will come through here, skip, and skip again. This is where our lowest thing will be, so this needs to come out a couple blocks farther, like that. And finally, our third line here. Now, I'll leave it to you to fill this stuff in with redstone. In particular, I might do some of it, just to show you where the repeaters can go, but a lot of the long buses, you can figure out the repeaters yourself. I don't need to hold your hand through that, and that's that. Alright, so next thing you want to do is have repeaters here, and this is kind of a strange thing to do, I'll tell you why in a moment. You want to grab some redstone comparators, which is an interesting thing to use in such a build, but that's what we're going to use, and stick them in front. Now the reason we have the repeaters there is just because... Oh, set all the comparators to subtract, because the comparators won't always be giving full signal strength, and we want full signal strength coming out, which is what the repeater's for. Now, in particular, we can bust this over. 1, 2, 3, 4, 5, 6, 11. All these should reach. 1, 2, 3, 4, 5, 6. Yep, these all reach. No, they don't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, most of them reach. That's good. In fact, we might be able to do something like this to make this one reach too. If we come out here and stick our repeater here instead, because there will be some signal strength coming out of this comparator, guaranteed. Oh, no, that won't work. Okay. Well, we can try. If we have to add an extra repeater, it's no big deal. We'll just need to add more delay to all the others. So now we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, we would need one more block. How could we do that? Oh, well, we can just add a repeater on here and have repeaters going in all these. Not too much of a problem. It'll just be one tick slower, which I guarantee you will not be nothing in the grand scheme of things. So there we go. There's that. And what these comparators are for is to provide a way to block the input from going in. So if we have inputs going in here, they'd come in with redstone, and they'd be on all the wires. Basically, what would happen is that we would have a line coming under here, connecting all these, and in particular, we want these repeaters to be on half slabs. There's even a sandstone half slab for them. So change all these repeater blocks to half slabs, and repeaters can go on them. So we'd have redstone on these blocks, and like this, come down, and like this. So this is a line that when we turn it on will block the signals from coming through. So right now, let's see what I mean by that. Right now, if I were to send a signal through, it should go straight up to the input shifter. And indeed it does. If we turn this guy on, however, if things work out, then... oh. These will need to be from... These signals will need to come from very far away for this to work, so... 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, repeater, like this. Now, if we try it, there's more signal coming into this side of the comparator than this side of the comparator, so when it subtracts it, it will find something negative, which it rounds to 0, and it will turn off. On the other hand, when we turn this line back off, it will go on. So this is just a way of doing a blocking system without using pistons. So you can stack this wire over if you want, and that is our top bus. The other one is exactly the same, like this, and yeah, there's that. Alright, now we can literally copy and paste this, I think. We'll need to add the repeaters here, but in this case, we can grab one position here, and for instance, go from this block. Copy, jump down here to paste it, and we'll just be missing these repeaters, which is fine. We can add them in. And that would be our bus. And the second step in this is to connect these two with glowstone towers. Hopefully, I'm living in hope that this reaches if we do it correctly. Although I'm not sure. But we might as well try it. 1, 2, 3, 4, 5, 6, 7, 8. Oh, maybe it will reach. 9, 10, 11, 12, 13. Perfect. So there's that. We connect these together with this glowstone tower, and finally hook up a repeater. And that should conclude this part. Hopefully we're not going to catch the wall. Ah, we will. Whatever. So we connect this part with a repeater, and now we have a device that connects all this stuff. I think that's pretty much what I had to do for today, honestly. Next time, we will extend this bus to include... Whoops, not 43 times. Whoops. We will extend this bus to include these wires here, and it will all connect together and look pretty cool. But yeah. On the other hand, we still have a ton of time, so I think we will just finish up this bus. It's a pretty neat thing to do, and it won't work, because we'll still need to connect some control logic, but it will be a nice looking bus coming in and out of the calculator. So, if I am correct, the one, we set our bit of 1 to be on this side. Yep, this is the 1 bit. In our calculator, this is the... If this is the 1 bit, it would be good. It would be convenient, and it is. So that's great. We won't have to do anything weird. Or not that much weird stuff, at least. So, let's see how this is going to be done. First of all, we'll make this come over here. Again, it won't interfere with any of the other buttons, don't worry. So we'll just bust these out individually, I guess. Shouldn't be too hard. And let me see, is this going to be lined up? I need to check if this is going to be lined up. Or if I'm going to need to move out further. I am going to need to move out further by a couple of blocks. That's a shame. By how many blocks? 1. Well, this block here is at z equals 1,682. This block here is at z equals 1,680. Okay, so we need to move out 3 blocks each. I guess that's not too bad. So to do that, we're going to come up here with a bus. And I suppose we should be making sure that we don't mess this up like this, so start coming down. Like so. Again, this isn't too difficult. I'm debating whether I have to show the building of all of these lines on camera, because it's pretty simple. When we hit the bottom of this staircase, then it will be time to move this over, so now we want to connect this like that. So there is that one. The next one, well, actually, if we want to do this, then we'll need to come out another bunch of blocks here, so I think that many, like this. So this should be just be connecting, like so. And I'm moving it over a little bit. Now, I'm not going to put redstone on these, you can do that. But I will just show the building of one more of these, and then the other two you will be able to do on your own, I sincerely hope. If you have any problems with it, you can leave it in the comments, but it's pretty easy. I don't think you'll have any problems with it if you've gotten this far in the series. So you're going to come up, and I didn't line that. Yes, I did. Like this, and bring this all the way in. So again, placing redstone on the wires and making sure the repeaters are in the right place is not hard. Adding the other two lines on is not hard. You can even stack some parts. But yeah, when I finish that, I'll get back to you, and I will show you how the finished bus looks. We should be just about at the end of this wire. There we are. One note, if you have trouble because your signals aren't reaching on this staircase and you aren't sure how to add a repeater onto here, you can do something like this with a double inverter. Have one thing like that. You lose one tick, but again, although the one tick signals add up, it's not too much of a price to pay, and it is kind of important. Well, here we go. This is what my bus looks like when it's done. So in particular, if we have a look at what we've done, this is what the whole bus looks like. We start from here. It goes up and around. Again, yours might look slightly different, but it should look something like this. Comes up and around, comes through here, splits off, connects to these control wires here, which did not get stacked, so you should put them back. And finally connects into the input shifters. So this is a decent amount of redstone you have done, a decent amount of busing you've done. We've gotten from there all the way down to our input panel, which is pretty cool. So that's about as much as I can do this episode, unfortunately. If you enjoyed, please make sure to leave a like and comment and subscribe and all that cool stuff. And yeah, and as always, well, bye now.